In the last video, we talked about how to convert from degrees to radians. Now we're going to talk about how to convert from radians to degrees. And the process is almost the same. We're still going to use that conversion factor. So remember that 180 degrees is equal to pi radians. And that's what we're going to use to convert. Okay, so let's suppose we want to know 5 pi over 12 radians. We want to know that equals how many degrees. So we want to find x. Okay, so I'm going to do my ratio again. So 5 pi over 12 equals x. Okay, so this is radians and this is degrees. Radians equals degrees, so I need radians down here. So I'm going to make sure I do the right order here. So I want to make sure the pi is down here. So that's pi, and that means 180 goes over here. Okay, now I have radians equals degrees, radians equals degrees. This works. Okay, now we can cross multiply. So 5 pi over 12 times 180. 5 pi over 12 times 180 equals, and now the other way, pi times x. Okay. And if I want to get the x by itself, I could divide both sides by pi, or equivalently, sometimes it helps to think of it like this. I could multiply both sides by 1 over pi. Because remember, you can multiply the same thing on both sides of an equation, and that also works. And then I think it's a little easier to see that the pi's cancel here. And then they cancel here too. If you want to divide by pi on both sides, that would also work. Okay, so now I have 5 times 180 divided by 12. And then on this side, I just have x. Okay, so I'm going to write the x first over here. And now let's see. 5 times 180 over 12. Okay, well, 180 and 12 can both be divided by 2. So maybe let's make that 5 times 90 over 6. Okay, and then 90 and 6 can both be divided by 3. So I could make that 5 times 30 over 2. And I think I can keep going here. Let's see. 30 and 2 are both divisible by 2. So that's 5 times 15 over 1. Okay, now I'm pretty much done. 5 times 15, you can either do that out by hand or do it on a calculator if you want. Either way, the answer is 75. And so I see that 5 pi over 12 radians, so let me write that down here, equals 75 degrees. Okay, let's try one more example. So I want to convert from radians to degrees, and let's suppose I have 6 radians. Now normally when you have radians, you'll have some kind of a pi in the answer, or in the expression, but not always. I mean, you could have 6 radians. That's a perfectly acceptable amount of radians. Okay, so let's do the conversion. So 6 equals x. So this is radians equals degrees. Radians equals degrees. So I remember that 180 degrees is equal to pi radians. Okay. And now I can cross multiply. So 180 times 6 equals pi times x. And so if I want to get x by itself, I can divide both sides by pi or multiply both sides by 1 over pi as I did in the previous example. Either one works. And so we would get 180 times 6 divided by pi. Okay, now this is a number that you could leave in terms of pi, but normally with degrees you would want to get an actual number. In other words, you would want to type this into a calculator. If your calculator has a pi button on it, you can use that for pi. Otherwise, you can approximate 3.14159, you know, however far out you want to go. But you wouldn't want to leave it like this. You would probably want to get a number. And so if you type this into a calculator, you get 343.7, and then I'm going to round it to the hundredths place there, 343.77 degrees. Now notice when we have an answer in radians, it's perfectly acceptable to leave a pi in the answer. But when we have an answer in degrees, we want to make sure we get an actual number.